So when I talk about the coordinate plane, we're talking about this two-dimensional space, this two-dimensional plane, I guess is what it's called.
Is that what we're writing now?
Yep, two-dimensional, or you could just say 2D. Okay, it's a 2D plane that's formed by the x-axis, which is the horizontal number line there, and the y-axis, which is the one that is vertical. And so then we're asked to label things here on the next part. And so, I don't like that color very well. So this blue, it would be a number line, all right? So negatives to the left, positives to the right, and that would be our x-axis. So that line is our x-axis. And then our y-axis is this one. So that's our y-axis. And the negatives are down and the positives are up. So it's like I've just taken a number line and put it vertically instead, kind of like a thermometer would be. And then where there's those two meet, here in the center, is the origin. As in the beginning, the origin of something, like the beginning. So any point on that graph or on that coordinate plane can be represented by an ordered pair. So, for instance, when we do the ordered pair, it's always going to be x and then y. So it is your horizontal coordinate first. And then the vertical coordinate, your y coordinate. So you can think of it like a grid. Like if any of you played Battleship, but of course then it was like B-22 or whatever. We're not going to start on bingo again though. But basically from the origin, my x coordinate tells me how far left or right to go. Left if it's negative number, right if it's positive. And then my vertical coordinate, my y coordinate, tells me how far up or down. And you guys have probably seen this before, but just to make sure we're all on the same page, so to speak, all in the same plane, all flying the same plane here. Oh, not that kind of plane. Are the four sections that are created, and they are numbered with Roman numerals starting in the top right where it's positive and positive. That is quadrant 1. This is quadrant 2, quadrant 3, and quadrant 4. So it's counterclockwise. We start at the top right, where both the x and y coordinate would be positive. Then second quadrant, the x would be negative, the y is positive. And then quadrant 3, we're to the left and down, so both x and y are negative. And quadrant 4, x is positive, but y is negative. So I was reminded that I was supposed to tell you that up there, because down here, we're going to be asked to identify which quadrant something is in. So for A, and remember that we are trying to find the point, not give the directions to that, where the letter actually is, but the point that's close to that letter. So A then is, of course, this point. So our ordered pair, first, how much from the left, from the center? 1, 2, 3, 3 or 4? 4?
I got
3. So negative 3. So negative 3 and 4. I will tell you that I don't know if it's because I'm getting older, because I don't remember having to do this so much until the last 5 years. But the way my eyes work now, I almost have to if it's more than a couple spaces, I have to almost physically touch it. I have to kind of physically touch it to count how many spaces, or I'm off almost every time. And which quadrant is that in? 2. That is quadrant 2. And B. 2. Negative 3. Good. So 2 to the right, and then down 3. And that is quadrant 4. And C. C is on one of the axes, so that one is one that people sometimes tend to mix up what the ordered pair is. So how much do we need to move left and right from the center to get to C? Nowhere. So 0 and then 2. Now, when it asks which quadrant, it really should say quadrant or axis, because if it's on the line, it's not considered to be in either quadrant. We would just say y-axis. And notice any point, and this will come up repeatedly throughout the course, any point that is on the y-axis, the x is going to be 0. Because if it's on the y, we don't go left or right, and that's why it's on the y. In contrast, any point that's on the x-axis is going to have a 0 in the y-coordinate, as the y-coordinate. So D there, how many spaces to the right? 7 and up 1. I could eyeball the 1, but not the 7. And that is, of course, both positive, so we know that is in the first quadrant. And again, if you didn't catch that when I gave you those quadrants, 1, 2, 3, 4 kind of makes a C, all right? And they are typically written in Roman numerals instead of our normal, what we usually use, our Arabic numbers. E. All right.
Negative 4.
Negative 4, negative 6.
Yep. It's in the third quadrant.
Good.
Hey, question. Do we have to put in parentheses? Is it?
Yes, you want the parentheses around your ordered pair, yes. Yep, put your ordered pair inside a set of parentheses. And then F.
Negative 6.
Negative 5, I guess.
I think negative 5.
I can't count.
1, 2, 3, 4, 5. Yeah, negative 5.
Yeah, negative 5.
And then it doesn't go up, so 0. Once I knew that this one was 7, then I was like, okay, it's 8 by 8. And then I'm like, okay, it's 3. I counted 3 from the side instead of over for the middle. So less jumping around for the eyes.
That's on the x-axis.
And that's on the x-axis. Perfect. So if it's on the axis, then we're just going to tell which axis it's on as opposed to which quadrant it's in. All right. So things on the borderline we'll list as on x or y axis. So you could be asked to give the ordered pairs for the points, or we could have the points, the ordered pairs, and then we have to place the points on the coordinate plane. We will have a chance to do some of both of those things. So when we look at a graph, what we just saw there would be considered a discrete graph. It's just individual points. Now, if you look that up on Google, I'm sure it would say something much more complicated than that. But these are just individual points. Whereas a continuous graph, continuous as it looks like, they are connected. So, for instance, when we get into graphing linear functions, doesn't mean it has to be linear, but it could be like this, and continuous as in there will likely be arrows on the end that we would, it keeps going. All right, so those would be like, it could be very different, right? But they would be connected. They're not just a bunch of disjointed points. You could have what's called a piecewise function, where you have like a segment, and then it picks up with another segment, and then another segment, but there is something on all the parts of the graph, and that it continues, right? So as we do things where we're identifying the domain and range, if it is a discrete graph, we can just make a list of points. But if it's continuous, and the points in between, like there's a line in between, we can't list every point because, like, what about 2.5 and all those things? Then we're going to have a different way that we're going to write that, and that kind of gets into that interval notation that I introduced briefly previously. So when we look at relations, let's see if I can get this where we can see everything at once. Maybe not at 250%. So we're going to talk about relations, and then we're going to talk about functions. Functions are special relations, all right? Kind of like a square is a special rectangle. A square is a special rectangle. Isn't that true?
I don't know. Never heard of it.
You've never heard that? You've never thought about that?
Never.
Okay.
Special.
Okay, so
A square is in a triangle is in a square.
no, I said a square is a special rectangle.
Special rectangle.
Rectangle,
Square.
right?
But it's a triangle.
So by definition, a rectangle, because the relation is not the special one, the function is going to be the special one. So any group of ordered pairs. They don't have to meet any special requirements. Sometimes we won't even see them in an ordered pair at first. And we're going to look at these ordered pairs, and we're going to write, like this could be represented in 4 different ways. And that's what we're going to look at. So all of the x values are called the domain. Okay? All of the x values, the set of all of the x's is called the domain, and the set of all of the y's is the range. Yes, very good. Is the range. Remember when we put it in the ordered pair, it's x and then y. And I sometimes remind people, if they're at all confused about that or tempted to do the other, to think it's alphabetical. X, Y. Well, guess what? Domain, range. it's still alphabetical. So sometimes that's just a little something that helps people if they're like, I can't remember which one is which. We'll probably talk about it enough, it'll get drilled in there, but just in case. So when I ask you here to tell me about the domain, I just want you to make a list of all of the numbers that are being used for X. Now, if a number is used twice, we only list it once. Okay? And typically, these are going to be listed. Now, when you do your lesson on IXL, it does not care if it's in order. But many times in a math class, it would be you could be required to put them in order from least to
I
greatest.
think there is some on IXL that I did last time.
That you had to do least to greatest?
Yeah, that had to be in order.
I don't remember it having to be in order, but if you listed the -3 twice, it would mark it wrong. Now, I'm not going to require that you make these fancy little braces here. It's just what's called set notation. It's just like kind of like fancy parentheses to keep that's the set of numbers that include everything that's being used for the X, the domain. Notice when I make my list for the range, they are not going to be like, they're not going to look like they're paired up anymore. Because I'm going to start with the lowest Y value, which is -4. And then my next lowest Y value is 0, and then 1, and then 2, and then 5. And notice also I don't have the same number of members in each because -3 was used twice. Okay, so if something appears more than once, we do not list it, but only the one time when we're listing our domain and range. So as a table, you do keep them paired up. We would just say -3, 1, -2, 0, 1, 2, 3, -4, -3, 5. Nothing super hard. It is one of those things where a little information goes a long way once you kind of know what the expectation is. And then next we're going to draw our mapping diagram. And for our mapping diagram, we're going to put them in least to greatest order. So if I have listed it that way here, it's going to be much easier to make my mapping diagram. The one on the left is going to be your domain. So I have -3, -2, 1, and 3. And then for my range, I have -4, 0, 1, 2, 5. About ran myself completely out of space there. Did not utilize my space at the top well. And then what we do is we connect them to pair them up the way they were in the ordered pairs. So -3 is paired with 0. Oh, 1. Thank you. Oh. Is paired with 1. There we go. And -2 is 0. And 1 is 2. And 3 is -4. And -3 is also paired with 5. And then for the graph, we're just putting the points on the graph, like the reverse of what we just did on the other page where we found the ordered pairs. So -3, 1. I'm going to make that big enough to see. -2, 0. 1, 2, 3, negative 4, and negative 3, 5. One, two, 3, 4, 5. There we go. So all of these represent the same function. When it's in this format, I don't know the individual points, right? I know that these are all the numbers that are used, but they could have been paired up very differently. So this is just a list, but this, all give me that same information because I actually know which ones are paired up with which. Yeah, I'll wait. So try the same thing. Work on doing the same thing with number 2, and I will do the same, and then we will compare our answers. All right, so I came up with negative 5, negative 4, negative 2, 3, 0, negative 3, 2, negative 5, and 4, 2. And again, in the ordered pairs, if you had those listed in a different order, as long as you have all 5 of them, hopefully we can agree on that it is those 5 points. And then now we can proceed through and do our answer our other questions like we had before. Hello. Make sure I work on my spacing to get everybody in here. And I see that there's nothing that repeated in my x's, so this one would be a function when we get to when we have to decide if it's a function or not. It would be a function. So in this case, we wrote the ordered pairs because we wanted everything filled in. We wanted to have our ordered pairs, we wanted to have our domain and range, we wanted our table, our mapping diagram. We wanted it represented in multiple ways. If you were just given the graph and only asked to give the domain and the range, you did not need ordered pairs, you did not need a mapping diagram, you did not need a table. You were only asked to do the domain and the range, but they were to be in order. Then we're going to see on the next page what we're going to talk about like scanning the graph. So if I were just going to get, if all I needed was these two answers, I could write down these first and then pull off the X's and pull off the Y's. But if this is all I need, then the quicker way would be for the domain, scan the graph from left to right. So looking from left to right, first time I hit a point, oh, that's -5. Keep going, oh, I got one on -2. I got one on 0. I got one on 2. And I've got one on 4. But go from left to right, and it would be in order from least to greatest. And then for the range, go from the bottom to the top. So we've got one down here at -5, -4, -3, nothing, 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 2, and 3. Again, it's not wrong to write these down first and then do this, but if this was the only piece of information you needed, you could save yourself some time. So those graphs were all discrete. They were all just individual points. They're not connected. When we look on this next page, we're going to see some graphs that are connected. Mm-hmm. And what's that? Hey Pedro, how are you?
Fine, just stop by real quick, say hi.
Pedro, recent graduate. Whoop, whoop. Are you starting some classes at Ivy Tech in another week or two?
No, I came to pick this up from Andrew.
Oh.
And yeah, gotta go. So,
Okay, see ya.
bye.
Good to see you. Thanks for stopping by. Pedro was our salutatorian, and he gave a speech at graduation, and he wrote something for Emily's class that was published in the, I don't remember what the local news, I don't know, I don't live in Noblesville, I don't remember what the local newspaper is called, but that's why he had newspapers, because she got some copies of it so that he could have copies. So, yeah, kind of cool. All right, so now we cannot list every number that this goes through, right? I mean, I could find all these points, but it also goes through all the section in between. So I cannot, like, does -3.5 work? Yes. How about -3.6? Yes. How about -3.88? Yes. I can't list all of those things. So like when we did our number line graphs and we said like less than something or greater than something, we can use that kind of thing or that interval notations. So for the domain, again, we're scanning for the domain from left to right, just like what I just talked about on the other ones, that we could scan from left to right. And we're seeing where we're kind of touching the graph, because sometimes there'll be some holes or some places where it's not going there. And then from bottom to top, for the range, scan your pencil. I guess that's going to say up and down, sorry. Or down and up, I don't know. I start at the bottom and go this way. All right, so for this domain, there is an arrow on the end, so it continues this direction forever and ever and ever and ever. There is an arrow on this side that continues forever and ever and ever and ever. So, are there any x values that we would not use? So it's going this way forever. It's going this way forever. It's So all the x values would be used. So for the domain here, we could say all real numbers. Now, this fancy R with like a double line is a symbol that means all real numbers. So you can just use that symbol. That's what it means, all real numbers. Remember, I showed you a little bit about interval notation. It would be from negative infinity to positive infinity. Typically, if it's all real numbers, I just write this. IXL, if they asked you that, you would just say there's like something they write out, all real numbers. All right? What about the Y's, though?
They're not.
Do we go all the way to the top and all the way to the bottom of the graph? No, this keeps going, right? And it's kind of going up. And so is this. So we would use all of the numbers going up, but we don't use all the numbers going down. What is the lowest that we do use?
-2.
-2. So we can say that the Y's are greater than or equal to -2. Because, starting with this, we use all the rest of the Y's. But we never use the bottom section of the graph. And that would look like this if I did interval notation. Starting from -2 and going up. And like I said, I think here we say, usually it's written using inequalities or interval notation. If it is all real numbers, that fancy R, tell us no, all real numbers. How about this circle? What numbers get used for the X? What's the smallest number we see getting used for the X?
-2.
And negative 3.
So it looks like -3 and 3.
Oh, yeah.
So for the domain, we would say, this one, the interval notation works kind of nicer, because we could say from -3 to 3, like that.
Doesn't matter if it's 3 and then negative 3.
You want to go least to greatest at the interval. And if you like the less than equal kind of thing, remember our compound inequality. We could say that -3 is less than or equal to x, which is less than or equal to 3. That also says that x is between those two numbers. Included, right? The equal line means that it also includes the 3. And what about the range?
3 and negative.
Yeah, the same, right? So we could write our range in the same way. Now, depending on the math textbook or the computer program or whatever you're using, you might also see this in the front. It might say X line and then that stuff. We would read that as X is such that it's between -3 and 3. Okay, so I don't typically write this, but if you see that extra thing, you're just focused on this part. And our range is going to look the same. So in this case, it does have ending, but we can't list every single point because there's all those decimal points between sections that we could not list. It would be an infinite number of precise points. And in this case, though, I said they would be the same, but here we would write a y, not an x. Right? So if you're using the interval notation, or you're using the, not interval notation, but if you're using the inequality and you're talking about range, you're talking about y. And if you're doing it for domain, you're talking about x. If there are arrows where it's going off the graph, off what we can see, then it can be that they are both all real numbers. So if you think about that going beyond what we can see on number 3, both are all real numbers, yes. Because eventually it would get to every point all the way to the left, all the way forever to the right, but also it's going down and it's going up. So any number could work for x, any number could work for y. How about number 4? What about our x's? For the x's, for the domain?
I'm sorry, for the y is real, for the x is not.
I think the opposite. I think the x is all real. Our domain is all real because it's going down, but it's also going down and out. So eventually, it's all the way to the left, all the way to the right. But the y is not all real because it gets up here and it gets that high, and then it turns around, right? It goes up, but it doesn't just keep going up. It comes back down. Now, it does go down forever, though. So we would say y is less than or equal to, how many up does it go? 1, 2, 3, 5?
5.
So y is less than or equal to 5. 5 is as high as it goes. We would say that this graph has a maximum. It has a high point. It doesn't have a low point because it keeps carrying on going down forever and ever. Number 5 is more similar to what we had with our circle. It does not go on in any direction forever. But they are not the same for our range and our domain like they were for our circle. So for our domain, what two numbers are our x's between?
-1 and 5.
-1 and 5. And as long as you start, if you use the inequality, if you start with the smallest, you would always be using the less than signs. Because when the x is in the middle here, this is really saying that the x is greater than, it's on the open side compared to -1, but it's less than. Okay, so as long as you go smallest to largest, it's always going to point to the left. And they both point the same way, and there aren't many little holes. If there was a little tiny hole right here, they would put like a little open circle, then we would not use the lines. But here we would use the lines. And for our range, looks like we're -3, +3.
Yes.
And if we're using inequality, be sure that you use y for the range. Or that's what that would look like. As the interval notation. Number 6. What do you guys think for our domain? Is there some limit on the x's that get used? No, it just keeps going, so all reals. And how about the range? Does it continue downward? Does it continue upward?
Yeah, real.
Yep, all reals too. On the following page, we have some that are going to kind of skip around a bit. There are some that have open circles. The open circles may not be, well, they definitely are probably not obvious from the screen. So this is probably either like sine or cosine or one of those trig functions. Not that you have to know that on number 7. So 7, the domain, it keeps going, right? It's going to go as far left and right. So that's going to be in all reals. But notice for the range, we're really limited. It never goes higher than 2. It never goes lower than, what, -3?
Yeah.
We've had a lot more all reals for domain, but number 8, our domain is actually limited and our range is all reals. So here, it would eventually go as high as infinity and as low as negative infinity, but the domain, there's a whole bunch of x's that don't get used. We don't start using x's until -1. So we would say x is greater than or equal to -1 because we don't use anything to the left of that. In number 9, sometimes people overlook this. This is the line they're talking about. That's our relation there. So what is the domain there?
All the rows?
What are we using for x?
Y is
For that orange line that I traced, what is x?
2?
X is 2 every single time, right? So this one, the domain is always 2. That's the only number being used for the domain. Now the range, it keeps going up, 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 and down, down, down. So the range is all reals. But the domain is staying the same. And then kind of the opposite thing happens in number 10. In number 10, the domain, it keeps going to the left, it keeps going to the right. So the domain is all reals, but the range is always -4. That's the only number that we're using for the range. It's just, the answer is always -4. And maybe you can, I guess maybe you can tell pretty easier than I thought. So in number 11, it's only that little segment, but at 5, that's open, so it's not included.
so -2 lesser or equal to x lesser than 5.
And then less than 5. Yes, good. So it starts out 2 to the left as far as the x, so -2. It goes up to 5, but because 5, the circle's not filled in, like our number line circles when we didn't fill them in, that's why there's no line here. Or if I used my interval, this one would get a hard bracket, and this one would just get a parenthesis. And then what about the range? What about for the y's?
1.
What is the lowest y?
-2?
-2 is the lowest y. Can it be equal to the -2?
No.
No, because that's the open circle.
Right.
And then the y,
One.
and then the 1, but this one corresponds to this one. I'm sorry, not 1, -1, right?
Yes.
-1. But that one does get the equal line because that circle is filled in. So notice these aren't in the same position because the lower number for the y is actually the point that's further to the right. These, from my eyeballs at least, all look like they're filled in. Would you guys agree?
Yes.
Okay. So what's the furthest we go to the left?
-4.
What's the furthest we go to the right?
5.
Uh-huh. So that's my comparison numbers. My x is between -4 and 5. So left to right has to do with the x, the domain. And then for the range, what's the lowest number that gets touched on the y? The lowest value for -3 is the lowest place, right? Because that corresponds with -3, which is here. So y, because we're talking about range. And then +5. We have an endpoint and an arrow. And the endpoint is an open circle. So from left to right, what is the furthest left?
2.
Okay, so the furthest, 2 is the furthest to the right. And there is no furthest left, right? It keeps going that way. So how could we talk about what are the x's that start at 2 and keep going to the left? We could say -∞ to 2. They would both get round parentheses. By the way, infinity always gets a round parenthesis. The 2 gets the round parenthesis because it's open. Or I could say that x is less than 2, but not equal to because it's not filled in. You would not need to give me both of those things. I'm just trying to show you both so you get used to seeing either of them. And what about for the y's?
All real.
Do we use the top section of the graph? So it can't be all reals for the range if we don't use the top section. What's the highest point that it touches?
0.
0. So our y is less than 0. Or we could say -∞ up to 0. Because it keeps going, heading down, but it doesn't go up. 14 is kind of the opposite situation in that it, as far as the y's, well, I guess the y's and the x's, right? Because we start someplace and we move to the right and up. So if we think about the place where there's an endpoint, here,
So -4 and infinity, function 2.
so -4. -4 would be over here for my range, right? Because that's the y coordinate.
Right.
That's the y.
Right.
So this one would be -2 to infinity, or I could say x is greater than, it's filled in, so or equal to -2. So what numbers are being used for x? Everything from -2 up. So x is greater than or equal to -2, or we can say, oh, I slipped up there. this would be a hard bracket, the square bracket. That's how we know that the -2 is actually included. And then for the range, that's where we would use -4, because that is the y coordinate of that point that I've circled. So the y's are greater than or equal to -4. All right, we're going to pause in the notes there, and I'm going to assign you some IXL lessons to do. So if you would, grab a Chromebook, or if you have your own device.